Lesson 15 is about surface area. Now in Lesson 8 we learned about area and basically how to calculate the area of a flat two-dimensional shape. Surface area is a little bit different in that we're dealing with a three-dimensional shape here, but we're still figuring out the area, and in particular the area of all of the surfaces that that shape has. Now in this textbook we won't be figuring out the surface area of weird geometric shapes like a rock or things like that, but just basic geometric shapes called right geometric solids. For example, what I've drawn here is a right rectangular prism, and we call it a right prism or a right solid because the base is perpendicular to the sides. And on these solids like this, these geometric solids, we consider the top and the bottom as the bases. Now I've gone ahead and added some dimensions to this right rectangular prism. And so let's go ahead and make this our first practice problem, and let's figure out the surface area for this prism. Now just think about what surface area means. That means the area of all of the faces or all of the surfaces. You already know how to figure out the area of a rectangle, and so you just have to look and you see that the faces of this prism, they're all rectangular in shape. So all you have to do on these is count up how many faces there are, figure out the area of all of those faces, and add them together, and that will give you the surface area. Now in that picture there, you can only see 3 faces, but think about it. Let's draw some dashed lines in here, and those represent lines that we can't see. And if you look now, you can see that there are several faces. You've got the one on the back, the front, the left, the right, the top, and the bottom. So you have 6 faces all together here. And actually you have 3 pairs of faces because there are pairs that are equal to each other. For example, this front face here, I'll put a blue mark on there, and the back face, those both have the same area, and they both have an area of 9 times 4. And so we can say 2, and then I'll do parentheses, 9 times 4. And then to that, let's add another pair of faces. For example, let's do the left and the right faces. And so here's the right one. The left one is over here. Those both have an area of 4 times 6. And so we'll say 2, since there's 2 of them, and then times 4 times 6. And then we have our top and bottom faces, and those, since there's 2 of them, we'll say 2 times 9 times 6. Okay, so now we have all of our surfaces, and let's just go ahead and do the operations we need to here. We have 2 times 9 times 4. That's 2 times 36, or 72. And then add 2 times 24, which is 48. And then add to that 2 times 54, which is 108. And let's add in pairs. 72 plus 48 is 120, plus 108 is equal to 228. Now our units there were meters, and we need to put meters squared because it's area, surface area. So that would be the total surface area for that right rectangular prism. So remember, on a right rectangular prism you have 3 pairs of faces, and you have to figure out the area of each of those pairs. Then you add them up, and that gives you your total surface area. Surface area, an application of that might be if you were painting a surface, and say it was a rectangular prism shape like this, and you needed to know how much paint you needed to buy. Usually on a can of paint it tells you this can of paint covers this much surface area. So you could calculate the surface area for your shape, and then you could know how much paint you needed to get. Another geometric solid that we'll be working with and calculating the surface area of is a right triangular prism. And again, it's a right prism because its side is perpendicular to the base. Now we've added some dimensions here, and we'll say that these are in inches. calculating the surface area of a triangular prism, it's similar to a rectangular prism in that we just figure out the surfaces or the areas of all the different surfaces and add them together. And right now you can only see two surfaces, so let's draw the hidden lines in, and that will help us to visualize what other surfaces there are. And now you can see that there are really 5 surfaces there. And there's a pair of surfaces that are the same, the front triangular and the back triangular surface. And so let's go ahead and calculate those first. There's 2 of them, so we'll say 2 first. They have a base of 7 and a height perpendicular to the base of 9. And then since they're triangles, divide by 2. So therefore the 2's will cancel here, and we just have 7 times 9. Now let's look at the bottom surface there. And so that would be 7 times 7. And let's just go ahead and do that in our head. That would be 49. And then we have the back face, which would be 7 times 9 is 63. And then let me just go ahead and make a little mark here. The front face, that's this one that's kind of at an angle there, that is 7 times 12. That would be its area. It's a rectangle. 7 times 12 is 84. Okay, so let's go ahead and add up now. We have 7 times 9 is 63. And 63 plus 49, that's equal to 112. And then let's add 63 and 84. That would be 147. And so then we can combine those two, and we'd end up with 259. And our units are inches here, so it's 259 square inches. So that's the total surface area for that three-dimensional shape there, that geometric solid. One difference between a triangular and a rectangular prism is that there are only 5 surfaces to calculate the area of, as compared to 6 in the rectangular prism. Next, let's talk about how to figure out the surface area of a right cylinder. Now, a right cylinder, it's called that because its sides are perpendicular to its bases. And again, we can draw a dashed line to represent that hidden side that we can't see. And now we can understand and see the 2 bases, the top one and the bottom one. Let's go ahead and add some dimensions here. We have a height of 11 centimeters, and then the radius for that base, that's equal to 3 centimeters. It's kind of hard to see the 3, but that's a 3 down there. Now for a right cylinder, there's basically 3 surfaces that we need to figure out the area for, to figure out the total surface area. 2 of those surfaces are identical. Those would be the bases, the top and bottom bases. The one that's different is this lateral or surface area around the sides. And that's going to be a new one, a new way of doing a calculation for area that we haven't done yet. The bases, those are pretty easy because they're both circular areas, and that's what a cylinder is. A cylinder is a circular tube, basically, like a Coke can or something. We know that the area for a circular shape is pi r squared. That's the formula that we use. There's 2 identical cylindrical or circular surfaces here, so we say 2 times pi, and then the radius is 3, so that would be 3 squared. And so let's just go ahead and do that calculation right now. That would be 2 times 9 pi, which is equal to 18 pi. Remember, pi is just 3.14, so we do 18 times 3.14, and that's equal to 56.52. And the units are centimeters, so it's centimeters squared. So that's just the surfaces, the top and bottom are surfaces of the bases. Now we need to figure out that lateral means side, or the area around the sides. The best way to understand lateral surface area is to get you a piece of paper, or just think of like a paper towel roll. The paper towel is rolled around that big roll, But when you tear a sheet of paper towel off, it's in the shape of a rectangle or a square. When it's wrapped around the paper towel roll, it's wrapped around the perimeter or the circumference of that roll. But then when we unroll it, it has a rectangular shape. So in the same way, if we could figure out the perimeter or the circumference of this circle, and then we know or multiplied it by the height, we would have a rectangular shape, and that would be our lateral surface area for that right cylinder. So that's what we need to do here to figure out the lateral surface area, and I'll just say LSA for lateral surface area. That's going to be equal to the circumference of this circle, which would be 2 times pi times the radius of 3, and then we multiply that times the height, and that would be times 11. And we think to ourselves, well, we're figuring out area, so we have to multiply a length times a length, and that's what we've done here, right? We did the circumference times the height, so length times length, and we have area. And so that's the area around that cylinder, around the sides of it. And so let's go ahead and simplify this. We'll have 2 times pi times 33, or 66 times pi. And so that would be 66 times 3.14. And so we just figure out that, and that's 207.24. And so now we have these two values. I have them right one above each other, the areas of the two bases, and then the lateral surface area. We just add those together and we get the total surface area for that right cylinder. And so 207.24 plus 56.52, that equals 263.76 centimeters squared. Now remember, on these problems where you're calculating area and things like that, I think it's fine to use a calculator on those. That's not the important thing on these problems, is to be able to do all the multiplication. The important thing is to know what formulas you need to do and how to apply those to calculate the area. One more type of problem where you'll be calculating the surface area is just of a right solid, and that is two bases that are perpendicular to each other. But it may not be just, an ordinary shape or a basic geometric shape like a cylinder or a triangle or a rectangle. Right solid problems, you solve those just like right cylinder problems. You figure out the area of the bases, and then you multiply that by 2, and then you figure out the lateral surface area by calculating the perimeter times the height. Usually what they'll do on these problems is they'll show you the base with all its dimensions. They'll show you that separately, and then they'll give you the height between the bases, and so you've got all the information you need to figure out the surface area for that right solid. So let's go ahead and figure out the surface area for this one, and we'll do it real similarly to the right cylinder. First, we'll calculate the area of the base, multiply that result by 2, then we'll get our lateral surface area. And so we look at our shape there to the right, the flat shape that's just the base and what it looks like, and we see that we have a rectangle and half of a circle. And so that rectangle has an area of 4 by 6, and then the half circle, we need to add that on, pi times a radius of 2 squared divided by 2, since it's half of a circle. And so then we end up with 24 plus 4 pi divided by 2. And we can cancel here, so we just end up with 2 pi. So that's 24 plus 2 pi, or 24 plus 6.28, and so that would give us 30.28 feet squared. And now remember, we need to multiply that by 2, because that's just the area of one base. We have two identical bases, the top and the bottom. And so let's do this by 2. And so then we end up with 60.56 feet squared. Now we need to do the lateral surface area. You can think about our paper towel example here again to figure out the lateral surface area. Let's just say we took some paper towel and started over here by the 5, and we wrapped the paper towel all the way around the side. So we go all the way around that way and then go back. And so that's basically the perimeter. We've wrapped that paper towel all the way around the perimeter of this shape. So if we can figure out the perimeter, we just need to multiply that by the height, and that will give us our lateral surface area. So our perimeter, we have one side that's 4 feet long, and then we have two lengths of 6 feet, so we can just say plus 12. And then we have that half of a circle up there at the top. And so we need to do the circumference of that. 2 times pi times the radius of 2. It's half of a circle, so we divide by 2. Okay, and so we're figuring out the circumference right now, so I'll just put a C out in front to the left so we know we're doing the circumference, or not the circumference, the perimeter. So we'll put a P in front of this to say P equals this, so we know we're doing perimeter. That'll help us keep up with things. And let's simplify here. We can cancel 2's right there. We have 4 plus 12 is 16 plus 2 times pi, or pi times 2. That's going to be 6.28. And so that equals 22.28. Now, as you can see, there's a lot to keep up with on these problems. You just need to try to stay as organized as you can. So now, that's our perimeter. Let's figure out the lateral surface area, or LSA. That equals 22.28 times the height of 5. So we need to multiply by 5. And so we can get our calculators to do that. 22.28 times 5, that's equal to 111.4. Okay, so that's our lateral surface area. So our total surface area then is equal to 111.4 plus 60.56. And so we can calculate that real quick. 111.4 plus 60.56. That's equal to 171.96 feet squared. That's our total surface area. Now, something else to think about on these problems, when you're doing problems where you're dealing with a circumference or calculating an area of a circular shape, on your calculator you may have a pi button that you can press instead of typing in 3.14. Now if you do that, your calculator has more decimal places than just 2. It's got an infinite number of decimal places basically. All these problems that we've done so far, we always round to 2 decimal places. We round pi to 2 decimal places. So if you use that button on your calculator, your answer may be a little bit different than the answer in the textbook, and that's just because of the rounding there. So what I would do in the textbook, they usually use 3.14 for pi, and so just so you know that you're doing the same thing that the book is, I would just go ahead and use 3.14 instead of using the pi button on your calculator, and that'll just eliminate some confusion. You won't get to a problem and say, oh, I did it wrong or whatever, because your answer might be slightly different. Now it may take you a little while to figure out how to calculate surface area. It's a fairly complicated process, and just because there's a lot of different steps. So you may want to review this lesson again as you need to. Okay, well that's all for lesson 15.